Yeah, we are live now. So, boys and girls, welcome back to my Massa channel, One Mentor. We are going to start chapter 2, that is units and measurement. We are going to start this chapter in a unique way, in a unique pattern. Okay, you might be knowing this chapter as units and measurement, but we'll try to understand a new concept from this chapter with a new logic and with a new concept. Let's start the scale of the large. Scale of the large. Scale of the large, scale of the universe, cosmology, and astronomy. So, here we start the chapter. So, let's start. What's in there in this chapter? The purpose of this video is to just begin to appreciate how vast and enormous the universe is. Frankly, our brain really can't grasp it. What we'll see in this video is that we can't even grasp things that we are actually super small compared to the size of the universe, and we actually don't even know what the entire size of the universe is. But with that said, let's actually just try to appreciate how small we are. This is me right over here. I am 5 foot 9 inches depending on whether I am wearing shoes, maybe 5 foot 10 with shoes. But for the sake of this video, let's just roughly approximate around 6 feet or around roughly 5 feet or 6 feet approx. I am not going to do into detail of the maths around 2 meters. Now if I were to lie down 10 times in a row, you would get about the length of an 18 wheeler. It's about 16 feet long. So this is times 10. Now if you were to put 18 wheeler, if you were to make it tall as opposed to long, somehow stand it up, and you were to do that 10 times in a row, and you'll get to the height of roughly a 60-story skyscraper. So once again, if you took me and you pulled me up 100 times, you will get about a 60-story scraper. Now if you took that skyscraper and if you were to lie it down 10 times in a row, you will get something of the length of the Golden Gate Bridge. And once again, I am not giving you the exact number. It's not always going to be exactly 10, but we are not getting to about something that's a little on the order of a mile long. The Golden Gate Bridge is actually longer than a mile, but if you go within the twin spans, it's roughly about a mile. It actually a little longer than that, but that gives you a sense of a mile. Now if you multiply that by 10 and you get to the size of a larger city, and this is right here in a satellite photograph of San Francisco. This is actual Golden Gate Bridge here, and when I copy and paste the picture, I tried to make it roughly 10 miles by 10 miles, just so you appreciate the scale. And that's interesting over here. And this is the picture interesting because this is the first time we can relate to cities. But when you look at a city on this scale, it's starting to get larger than what we are used to processing on a daily basis. A bridge, we have been on a bridge, we know what a bridge looks like, we know that a bridge is huge, but it doesn't feel like something that we can't comprehend. Already a city is something that we can't comprehend all at once. We can drive across the city, we can look at satellite, imaginary, but if I were to show a human on this, it would be unbelievably small. You won't actually be able to see it, would be less than a pixel on this image. A house is less than a pixel on this image. But let's keep multiplying by 10. If you get multiplied by 10, again you get to something roughly the size of the San Francisco Bay Area. This whole square over here is roughly that square right over here. Let's multiply it by 10, again by 10. So this square is about 100 miles by 100 miles. So this is one would be about 1,000 miles by 1,000 miles, and now you are including all of a big part of the western United States. You have California over here, you have Nevada here, you have Arizona and New Mexico. So, a big chunk of a big continent we are already including. Frankly, this is beyond the scale that we are used to operating. We have seen maps, so maybe we are a little used to it. But if you ever had to walk across the type of distance, if you would take for a while to some degree, the fact that planes go so fast, almost unimaginably fast for us, that is made it feels like things like continents aren't just big because you can fly across them in 5 or 6 hours, but these are already huge distance. But once again you take this square that's about 1,000 mile by 1,000 mile and you multiply that by 10, and you get pretty close, a little bit over the diameter of the earth, a little bit over the diameter of the earth. But once again, we are on the earth. We relate to the earth. If you look carefully at the horizon, you might see a little bit of a curvature, especially if you were to get into the plane. So, even though this is frankly larger than my brain can really grasp, we can relate to the earth. Now, you multiply the diameter of the earth times 10 and you get to a diameter of Jupiter. So if you were to set Earth right next to Jupiter, obviously there were no ever near that close. That would destroy both of the planet. Actually, it would definitely destroy Earth. It would probably just be merged into Jupiter. Earth, so if you put Earth next to Jupiter, it would look something like that right over there. I would say that Jupiter is definitely, you went on this diagram that I am drawing over here, is definitely the first thing that I can't comprehend. I mean, the Earth itself is so vastly huge. Jupiter is 10 times bigger in diameter. It's much larger in terms of mass and volume and all the rest, but just in terms of diameter, it is 10 times bigger. But let's keep going. 10 times Jupiter gets us to the sun. This is times 10. So if this is the sun and if I were to draw Jupiter, it would look something like, I'll do Jupiter in pink. Jupiter would be round than big. And then the earth would be around that big if you were to put them all next to each other. So the sun once again is huge. Even though we see it almost every day, it is unimaginably huge. Even the earth is unimaginably huge, and the sun is 100 times more unimaginably bigger. Now we are going to start getting really wacky. You multiply the diameter of the sun, which is already 100 times the diameter of the earth. You multiply that times 100, and that is the distance from the earth to the sun. So I have drawn the sun here is a little pixel, and I didn't even draw the earth as a pixel because the pixel would be way too large. If you would have to be 100th of a pixel in order to draw the earth properly. So this is an unbelievable distance that between the earth and the sun, it's 100 times the distance of the diameter of the sun itself. So it is massive. But once again, these things are relatively close compared to where we are about to go. Because if we want to get to the nearest star, so remember the sun is 100 times the diameter of the earth. The distance between the sun and the earth is 100 times that. Or you could say it's 10,000 times the diameter of the earth. These are unimaginable distance. But to get to the nearest star, which is 4.2 light years away, it's 2 lakh times, and once again unimaginably it's 2 lakh times the distance between the earth and the sun. And to give you a rough sense of how far apart these things are, if it was roughly the size of a basketball, if the average star was about the size of a basketball in our part of the galaxy in a volume the size of the earth, so if you had just like a big volume, the size of the earth. If the stars were the sizes of basketballs in our part of the galaxy, you would have only a handful of basketballs per that volume. So unbelievably sparse, even though the galaxy looks like, even though we when you look at the galaxy, and this is just an artistic depiction of it, it looks like something that has the spray of stars, and it looks reasonably dense, or you can say dense. This is actually There is actually a huge amount of space that most the great majority of the volume in the galaxy is just empty space. There there's no star, no planet, no nothing. I mean, this is a huge jump that I am talking about. And then if you really want to realize how large a galaxy itself can be, you take this distance between the sun, or between our solar system, and the nearest star, so that 2 lakh times the distance between the earth and the sun, and you multiply the distance by 25,000. So if the sun is right here, our right, or our nearest star, will be in the same pixel. They will actually be within, I mean, you would have to get a ton of stars within that one pixel, even though they are so far apart. And then this whole thing is 100,000 light year. It's 25,000 times the distance than the distance between the sun and the nearest star. So we are talking about the unimaginable, unfathomable distance just for a galaxy. And now we are going to get frankly, my brain is already well beyond anything that it can really process at this point. It almost just becomes abstract thinking. It just becomes playing with numbers and mathematics. But to get a sense of the universe itself, the observable universe, and we have to be clear, because we can only observe light that started living from its source 13.7 billion years ago, because that's how old the universe is.